Imagine walking along your favorite beach, only to find the waves glowing with an eerie blue light at night, and the shoreline littered with thousands of dead fish the next morning. This isn't science fiction, it's red tide, and it's one of the ocean's most haunting natural phenomena. It starts quietly, invisibly, a single-celled organism called Karenia brevis, drifting in the Gulf of Mexico. Under the right conditions, it begins to multiply. One becomes a million becomes a billion. Soon, vast stretches of coastal water turn rusty red or murky brown. The air near the shore begins to smell sharp, almost like pepper. People cough. Birds avoid the area. And then the fish start washing up lifeless by the thousands. This is red tide, a natural disaster written in microscopic script, and its impact is anything but small. But what exactly triggers these deadly blooms? And how can something so small wreak so much havoc? Let's dive into the strange, silent world of algal blooms, where life, death, and chemistry collide in the waves. For centuries, sailors and coastal communities have recorded strange blood seas and sudden mass fish deaths. We now know these events were red tides, natural algal blooms caused by dinoflagellates, tiny organisms that can photosynthesize like plants but swim like animals. Under normal conditions, they exist in harmless numbers. But when temperature, sunlight, and nutrient levels align just right, their population explodes. A single liter of seawater can contain millions of these cells. At that density, they release potent neurotoxins called brevetoxins, invisible, odorless, and deadly to marine life. But it's not just the toxin that's dangerous. It's the scale. A major red tide can cover hundreds of square miles, turning vibrant ecosystems into marine graveyards in a matter of days. So how does this happen? Let's break it down step by step. It usually begins offshore, where deep, nutrient-rich waters well up toward the sunlit surface. Karenia brevis, the most common red tide culprit in places like Florida, thrives in warm, salty water. When coastal runoff from agriculture or urban areas adds extra nutrients like nitrogen and phosphorus, it's like pouring fuel on a fire. The algae reproduce rapidly, forming what scientists call a bloom. But here's where it gets eerie. These organisms are bioluminescent. At night, when the water is disturbed by waves or swimming fish, they emit a ghostly blue glow. It's beautiful, but it's a warning sign, a signal that the bloom is intensifying. As the bloom grows denser, it starts to affect the water itself. The algae consume so much oxygen that parts of the ocean become dead zones, areas where fish and other marine creatures literally suffocate. At the same time, the brevetoxins they release attack the nervous systems of fish, manatees, dolphins, and even birds. Fish lose coordination, swim erratically, and soon wash ashore. Sea turtles that eat affected fish become paralyzed. For marine mammals like dolphins, the toxins accumulate in their prey, leading to slow poisoning over time. In one severe red tide event, over 200 manatees died, a devastating blow to an already vulnerable species. But the danger doesn't stop at the water's edge. When waves break, toxins can become aerosolized, carried by the wind in a fine, salty mist. People walking on the beach may experience burning eyes, coughing, and difficulty breathing. Those with asthma or other respiratory conditions are urged to stay indoors. It's a surreal experience, standing on a beautiful beach, surrounded by blue sky and waves, yet feeling like you're breathing in something toxic. And it's not just the air. Shellfish like clams and oysters filter these toxic algae from the water, concentrating the poison in their tissues. Eating just one contaminated shellfish can cause neurotoxic shellfish poisoning in humans, with symptoms ranging from nausea and dizziness to partial paralysis. That's why during a red tide, shellfish harvesting is shut down completely. What's fascinating and troubling is that these events may be becoming more frequent and intense. Warmer ocean temperatures from climate change, combined with increased nutrient pollution from human activity, create ideal conditions for algal blooms. Some scientists believe we're entering an age of super blooms, longer lasting, more toxic, and more widespread than ever before. But there is hope. Researchers are now using satellites to monitor blooms from space, developing early warning systems that give communities time to prepare. In some areas, experimental clay spraying is used to sink the algae out of the water column, reducing toxin levels. Oyster restoration projects are also helping. These natural filter feeders can clean thousands of gallons of water a day. Reducing the nutrients that fuel bloom's red tide is a powerful reminder of how delicate the balance of marine ecosystems really is. A microscopic organism, invisible to the naked eye, can reshape coastlines, threaten human health, and wipe out entire populations of marine life. Yet, it's also a natural process, one that's been occurring long before humans walked the earth. The challenge now is to live alongside these blooms without making them worse, to reduce nutrient runoff, protect wetlands, and support the science that helps us predict and respond. Because in the end, red tide isn't just a coastal curiosity. It's a mirror reflecting our relationship with the ocean. And what we see in that reflection will determine whether these crimson waves remain a rare event or become a recurring nightmare. Have you ever witnessed a red tide or another algal bloom? Share your experience in the comments, and if you want to dive deeper into the mysteries of the natural world, subscribe to Nature Unlocked.